Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be doing part 2 of appropriate data displays. Remember, in this video, you're going to get a chance to practice what you know. Let's get started. Okay, let's jump right in with our questions, see how you do. The histogram below was created to depict the hourly wages of 100 employees at a department store. Use the information depicted on this graph to answer the questions that follow. So, first of all, identify the difference between the number of people who earn the lowest wages and the highest wages. Is it A, 17, B, 27, C, 20, or D, 7? Good luck. How did you do? The answer to that one was B. 30 employees earned between $6.50 and $8.50. The lowest wages, 3 employees earned between $16.51 and $18.50. The highest wages, and the difference between 30 and 3 is 27. Let's try another one. What conclusion can be drawn on average about the hourly wages at the department store? A, as the hourly wage increases, the number of employees increases. B, the majority of employees make between $16.51 and $18 per hour. C, as the hourly wage increases, the number of employees decreases. Good luck. So the answer to that one was C. The majority of the employees earn lower hourly wages. Only a few employees are really earning the top wages. Here's another example. Let's try this one. The stem and leaf plot below was created to compare scores of 2 golf teams composed of 10 players each. Use the information on it to answer the questions that follow. If you need to pause your video to take a closer look, feel free. And the question is, which team has the greater range in scores? How did you do, everybody? The answer is Team 2. The range in scores for Team 2 is 36. And the range in scores for Team 1 is 35. Okay, let's take a look at what's written here in blue. Which statement about the stem and leaf plot is true? A, the median score for Team 1 is greater than the median score for Team 2. B, the median score for Team 2 is greater than the median score for Team 1. Or C, the mode for both Team 1 and Team 2 is 84. Good luck. All right, guys, how'd you do? The answer to that one was B. The median score for Team 1 is 83.5, and the median score for Team 2 is 84. So let's take a look at what we've got here. Different data displays are used for different reasons. Bar graphs best depict unconnected values, whereas a line graph depicts a continuous trend among the data. A stem and leaf plot organizes the data by showing the data values in order. A stem and leaf plot is useful in determining the mean, median, mode, and range for a set of data. The distribution of data items is depicted on a box and whisker plot, in which the data is divided into 4 quartiles, and a histogram shows the frequency of data on a graph. So these examples will help us learn about the most appropriate graph to display a given set of data. Let's take a look at an example. The data table below depicts the amount of money Mary had in her savings account each month over the course of 1 year. Choose the most appropriate display for the data. So if you need to, pause your video and take a look at that, the deposits and the months. So since the data table depicts values over time, a line graph would probably be the most appropriate way to display the data. Another example, the data listed below depicts the ages of students who participated in the National Spelling Bee. Choose the most appropriate display for the data, and there's their ages. Good luck. All right, since the data values are similar in range, create a histogram to depict the frequency of the ages of the students who participated in the spelling bee. Recall that to create a histogram, we have to first arrange the data on a frequency table. Another example, the data values listed below depict 2 periods of students' scores on a history exam out of 100. The teacher grading the exams would like to create a display that will compare the 2 sets of data and would allow him to eventually determine the overall mean, median, mode, and range of the test scores. What's the most appropriate display for this set of data? Good luck. All right, how'd you do? A stem and leaf plot will allow for the best comparison of the 2 sets of data. A stem and leaf plot will also arrange the data values for determining the mean, median, mode, and range. Recall that the first step in creating a stem and leaf plot is to arrange the data in order. You can use all you've learned about displays to collect, organize, and analyze real-world data. So, in the following example, we're going to create multiple displays to depict the same set of data. So, this is our last one, so do your very best. The table below depicts the mean temperature, measured in Kelvin, of each planet in our solar system. Use what you've learned in the past lessons to display the data from the table on a bar and line graph, a stem and leaf plot, a box and whisker plot, and a histogram. So we got 4 jobs. There's the data that we need, the temperature in Kelvin for each planet. Pause the video if you need to. So let's start here. Looking at the decreasing bars and lines on the graph, you can conclude that a planet's location affects its temperature. Planets closest to the sun have a higher temperature, and planets furthest from the sun have the lowest temperature. So it's evident that Venus has the highest surface temperature, and Neptune has the coolest surface temperature. Now let's look at a stem and leaf plot. Looking at this, we can determine that none of the data share a stem. So therefore, there's not going to be a mode for this set of data. The coolest temperature is 37 Kelvin, and the warmest temperature is 726. And the difference between the two extremes, or the range, is going to be 689 degrees Kelvin. The data values in the middle are 120 and 285. So therefore, the median planet temperature is 202.5, and the mean planet temperature is 254. So we add them all up and divide by the number of values, 8, and we get 254. We can also create a histogram of the data too. So look at the frequency table and the histogram that we've created here. You've got your tallies and your frequency, and then we can create the histogram. Here are the conclusions that we can draw. Looking at the histogram, it's apparent that most temperatures fall between 0 and 200 Kelvin. 3 planets have surface temperatures that fall between 201 and 400. None of the planets have a surface temperature between 401 and 600. 1 planet has a temperature between 601 and 800 Kelvin. So the most important thing that we need to remember is that by looking at the same data in different ways, we can become very, very familiar with the data. In one visual way, it may make more sense to you than another, but no matter which ones you create, you can use visual displays of data to answer questions and draw conclusions. Thanks so much for joining us. We'll see you next time. Bye-bye.